Hey there, gang. In this next lesson, we're going to talk about what it means for figures to be similar and congruent. So, similar figures are those that have the same shape, but not necessarily the same size. Okay, so you can see below here in this chart an example of two triangles that are similar. See how they have the same shape. They're both triangles. They're both the same type of triangle, but one is obviously smaller than the other one. Those are examples of similar figures. These two triangles here, even though they're both triangles, one is a right triangle and then one is a not right triangle, and so those would be not similar figures. Congruent figures are figures that have both the same size and the same shape. So an example of two congruent figures is what you might see down here. These two parallelograms are congruent. Okay, if you were to turn this parallelogram here to its side, it would be congruent to the first one. However, these two triangles down here, even though they're both right triangles, they are not congruent because they're not the same size. So these two triangles down here would be what we call similar, but not congruent. Okay, so that's what our job is going to be on 1 and 2 here on the first page, is just to tell whether each pair of figures appears to be congruent, similar, or neither. So number 1, we have these two parallelograms, and one appears to be smaller than the other one, so we would call these similar figures. Okay, they both have the same shape, but they are not the same size. Number 2, these two figures, they're definitely not congruent because they're definitely not the same size, and they're also not the same shape. Even though both of these figures are pentagons, they both have 5 sides. This pentagon on the right is not the same as this pentagon on the left. The one on the left appears to be a regular pentagon, whereas the one on the right has its sides all with different lengths. So we would call these neither similar nor congruent. Okay, moving on to corresponding sides. So the sides of congruent or similar figures that are in the same position, okay, same position, are what we call corresponding sides. And so by same position, I mean if you look down at these two triangles we've drawn here, triangle FGH and triangle XYZ, the sides in the same position would be the ones that are color-coded here. So this side on triangle FGH, its corresponding side on triangle XYZ would be the side that's in the same position. Okay, this line segment XY. When you have congruent figures, the corresponding sides are equal. And that makes sense because since congruent figures have to be the same size, then corresponding sides must also be the same size. So any corresponding sides on congruent figures have equal side measures. When you have similar figures, and that's what we have down here in this picture, then the corresponding sides aren't necessarily equal, but the ratios of the corresponding sides are equal to each other. Okay, so that means if this side here FG, let's say, is 6, and then this side here XY is 3, well, the ratio of 6 to 3, 6 divided by 3 is 2, must be the same as the ratio of the side GH to the side YZ. So that means if the side GH, let's say, was 8, then the side YZ must be 4, because since 6 divided by 3 is equal to 2, then the same has to be true over here. This side, 8 divided by 4, must also be equal to 2. So that's what it means for sides to be corresponding in similar figures, is the ratio of the sides are equivalent to each other. So we're going to jump down here to examples 3 and 4 and look at these similar billiard tabletops or pool tabletops. We have two rectangles here, rectangle STUV and rectangle WXYZ. And number 3 asks us what side of rectangle WXYZ corresponds to segment TU. So let's go to the big rectangle first. Segment TU is this one here on the right. This is segment TU. And so what side of the smaller rectangle, WXYZ, would correspond to this side? Well, it would be the one in the same position, so this one, and that is segment XY or YX. Okay, so we would say segment XY for number 3. Number 4 asks, what side of rectangle STUV corresponds to segment WX? Okay, well, using some similar logic, segment WX and the smaller rectangle is here on the top. And so if we go to the larger rectangle, the side in the same position is this line segment here, and this is line segment ST or TS. So we would say line segment ST corresponds to line segment WX. Okay, finally jumping down to 5 through 7, we're asked to state whether each rectangle in 5, 6, and 7 is similar to rectangle WXYZ up here at the top. Okay, so for WXYZ, we know that the top side segment ZW measures 12 units, and then segment WX measures 4 units. And because it's a rectangle, that also means that the opposite sides are congruent. Okay, we learned that the other day when we talked about properties of quadrilaterals. Okay, so that means that this side here must also be 4 units, and then the bottom side must also be 12 units. Okay, so let's look at rectangle number 5. We have the top segment measuring 8 units and the bottom segment measuring 2 units. And remember, in order for two figures to be similar, the corresponding sides have to have equal ratios, okay, or the ratio of the corresponding sides have to be equal. So let's take a look at the top of this rectangle. The top measures 8, and for our larger rectangle, the top measures 12. So the ratio of the rectangle in number 5 to our rectangle WXYZ for those top sides is 8 to 12. Okay, 8/12 reduces to 2/3. Now let's check the ratio on these other two sides here. So on the right side, we see we have a measure of 2 on this smaller rectangle. For my top rectangle up here, that's a measure of 4, so that ratio is 2 to 4, which reduces to 1/2. 2/3 and 1/2 are not equal to each other. Those ratios aren't equal. Okay, so we would say that for number 5, these two rectangles are not similar. Okay, let's try that again for number 6. So number 6, my top side measures 18 units. And again, we're comparing it to the top rectangle, which measures 12 units. So we have 18 to 12. That reduces to 3/2. So the ratio is 3 to 2. Now let's look at this right side here. This rectangle measures 6 units, and we're comparing it to 4 units for our top rectangle. 6 to 4 reduces to 3/2, 3 to 2. So both of these ratios are equal to 3/2, and so because these ratios are equal, we could say that number 6, this rectangle, is similar to our original rectangle. So these are similar figures for number 6. Alright, I want you to pause the video really quickly and try number 7 on your own, and then once you think you have your answer and your work shown, click play to check. Okay, the same process for number 7. So we're comparing the top side on this rectangle 9 to the top side on our original 12. So 9 to 12 reduces to a ratio of 3 to 4. And then comparing the other sides, 3 to 4 doesn't reduce, it is just 3/4. And these are, in fact, equal ratios. So we can say that rectangle 7 is also similar to the top rectangle. Alright, as always, if you have any questions over this video, be sure to jot those down so that I can address those the next time I see you. And until then, have a nice day. You're all wonderful people. Take care.